Welcome to my channel. I'm Zhang Xu. Let's look at the problem 57 in chapter 24. Chapter 24 is about capacitance, dielectrics, and electric energy storage, right? So this is a follow-up problem for problem 10. The problem 10 tells us the cell capacitors quantities, right? It tells us the capacitance for this capacitor is 35 farads. And also the distance between two planes are 2 nanometer. We write it there. And also tell us the dielectric constant is 25. And also we can get the constant epsilon naught in our textbook. And first one, determine the area A of the cell capacitor planes. So we can see, as we know the quantities C, D, K, epsilon naught, can you find A? Sure, very straightforward, we can get the function. We can consider the equation for capacitance, right, for capacitor. You can see in this function, C is given, K is given, epsilon naught is given, D is given, so only unknown quantity is A. So we can convert this equation, get the function for A, and then input all the given quantity, we get answer there. The part B tells us the capacitor was mounted on a silicon-wafer surface with its planes parallel to the plane of the wafer. Assume this A accounts for half of the area each cell, so it accounts half of, so keyword half, right? Ask you how many megabytes of memory can be placed on this 3.0 centimeter square silicon wafer. So now we can see just half of the cell is used for capacitor. So now the areas in the capacitor total is 1.5 centimeter squared. Do you agree? Yes, because it tells us half. Now you can see the total areas is 1.5 centimeters, but for one capacitor, the areas is 0.32 right, micrometer squared. Now ask you how many capacitor we have. So now we just use the total areas 1.5 centimeter squared divided by the areas for each capacitor, right? 0.32 micrometers. And in this case, we can consider this is the number of capacitors we have, right? Yes. And we can consider one capacitor is 1 bit, right? Ask you how much of the megabytes. So that is 8 bits equals to 1 byte, right? So we use this ratio, then we do this calculation, we can get the number of bytes, and then convert the unit, we get the unit in megabytes. Thank you.